Good morning students, I am your Nagini ma'am. Today I am going to discuss about the differences between ideal and non-ideal solutions. Okay students, so first of all, what is Raoult's law? Raoult's law means the partial vapor pressure of each component in the solution is directly proportional to its mole fraction. Correct? So for example, I am taking the solution of two volatile liquids. The partial vapor pressure of each component, for example, the binary solution I am taking, in the binary solution two components will be there. Suppose the two components, solution 1, solution 2, two components I am taking students. So the two components partial vapor pressures vapor pressures are directly proportional to their mole fraction students. So that is the Raoult's law. So we can write it as P1, suppose P1, P2 are the two components partial vapor pressures and the mole fractions x1, x2. Then according to the Raoult's law, we can write it as P1 is directly proportional to x1, P2 is directly proportional to x2, correct? So like this we can write. This is the statement of Raoult's law students. Clear this one? So that is, now I'm going to discuss about the differences between ideal and non-ideal solutions. Okay students, so coming to the ideal solution students, what is the ideal solution? Obeys the solutions which obeys the Raoult's law at every range of concentration. That means they obey Raoult's law. Clear this one? So what is the first point students? They obey Raoult's law. Obey Raoult's law. So ideal solutions obeys Raoult's law students. What about non-ideal solutions? In non-ideal solutions, again two types of solutions are there students. Some solutions are showing the positive deviation from the Raoult's law and some solutions are showing the negative deviation from the Raoult's law students. So here again two types are there. So what is the first type students? Positive deviation. What is the first type? Positive deviation from the Raoult's law. Positive deviation from Raoult's law. Okay, and second type is negative deviation. Negative deviation from Raoult's law. Okay, from Raoult's law. So here two types are there students. Now coming to the positive deviation from Raoult's law students, again same thing here. Non-ideal solutions do not obey Raoult's law students. Even positive deviation, negative deviation, both cases students, in both the cases solutions they do not obey Raoult's law students. Okay now, so what is the point students here? First point, do not obey Raoult's law. Do not obey Raoult's law. Here also do not obey Raoult's law. Clear this one? They do not obey Raoult's law students. Clear this one? So this is about the first point. Now going to the second point students, AA, AB, BB interactions are same. That means A and B are identical in shape, size and character students. Here first, what is the second point students? AA, AB, BB interactions are same. Clear? So AA, AB, BB interactions are same students. That means what? AA means what students? Suppose A is the component solute, B is the component solvent students. So solute, between the solute and solvent, between the solvent and solvent, attractive forces, and between the solute and solvent. That means solute is added to the solvent students, then we will get the solution. So this is the solution, this is the solute to solute, this is the solvent. In between the solute and solute, between the solvent and solvent. Okay now, and here I am taking the AB two components, suppose solute and solvent. Clear this one? Here I am taking the binary solution kada, two components will be there. Okay now, this is the first component here, this is second component, this is the first component. Between the first components AA and between the components BB and the components between the components of A and B, attractive forces are same students. In this case ideal solutions. Are you following, students, here? Okay now, so here I'm taking the two components. Okay now, so two components I'm taking, because here I'm taking the binary solution. In the binary solutions, suppose two components are present. If suppose a b two components are present, in between the a components and between the b components and between the a b components, attractive forces are same, students. Clear? In this case, positive deviation. Okay now, why here interactions are same means because a and b both components are identical in shape, size and character. Clear this one? Why, Nana? So that is a and b are identical in shape, size and character. Clear this one? Okay now, they are identical in shape, size and character, students. Now coming to the positive deviation from the Raoult's law, students, here AB attractive forces are weaker, students. That means in between the two components AB attractive forces are weaker than AA and BB attractive forces. Clear this one? Okay na? So attractive forces, why, students? A and B have the different shape, size and character, correct? So that is A and B, two components have different shape, size and character. Clear this one? Okay, now coming to the negative deviation, here, students, in between the two components A and B, attractive forces are weaker than AB, than which one, students? AA components and BB components. Clear this one? So in between the same components AA BB components, attractive forces are strong, students, when compared to the different components attractive forces. Okay now, so this is the solution, students. This is the first component, this is second component in the solution. So attractive forces are different because A and B have the different shape, size and character. Now see, students, here in this case AB attractive forces are greater than AB attractive forces. Okay, AB attractive forces are greater than AA and BB. Clear this one? BB attractive forces. That means here also same thing, students. Here attractive forces, BB attractive forces, that is A and B, two components have different, okay na, different, they have different, which one, students? Different shape, size and character, students. Different shape, size and characters. Clear this one? This is the second point. Okay now, so this is the case of ideal and non-ideal solutions. This is the second point completed, students. Now I am going to discuss the third point, students. Okay now third point, delta H mixture equal to 0, students. Here delta H, that is change in enthalpy, students. Here delta H value is 0. That means here neither heat is evolved nor absorbed during the dissolution, students, because attractive forces are same number in between the two components AA, AB, BB components. Attractive forces are same because they have the same size, shape and character. So that's what will happen, students. First of all, suppose the component AA and the component BB, between them attractive forces first have to break, correct? Then only the component A, the component B, both are mixed with one another, then we'll get the solution, correct or not? So first of all, in between the A components, in between the components B components, attractive forces first of all have to break. So that's why to break the during the breaking of bonds, students, or during the breaking of attractive forces, we have to supply some energy, students. Some energy is required, correct? And here AB component is there. See here between the solute and solvent, that means two components. In between the two different components, attractive forces here also, here and here, all the attractive forces are same, correct? So here between the component AA, between the same components, attractive forces are attractive forces. To break them, we have to supply more, we have to supply energy, students. the energy is required during the breaking of bond. Attractive forces, during the breaking of attractive forces, energy is required, and during the formation of new bond, students, energy is released. Keep in your mind, students. Okay, now during the breaking of bond, energy is required, students. During the formation of bond, energy is released. Now in the case of the component, same components AA and BB, attractive forces are same. So that's why here same amount of energy is required, students, to break them. And after that, AB components, in between the components, that means new bond is formed between the component A and component B. That means during the formation of new bond between the two components, students, here energy is released. Here how much amount of energy is required? Here the same amount of energy is released, students. Are you following? So during the chemical reaction, so that's why here delta H is equal to 0. That means what we can say, students, neither heat is evolved nor absorbed during dissolution. Correct? Neither heat is evolved nor absorbed. Clear? Absorbed during the dissolution. During dissolution. Now coming to the positive deviation from Raoult's law, students, what is the third point? Now coming to the third point, students, here positive deviation from the Raoult's law. Third point. What is third point, students? Delta H value is greater than 0. Change in enthalpy is greater than 0, students. Delta H greater than 0. Delta H mixing. That means here delta change in enthalpy. Change in enthalpy is how much, students? Mixture greater than 0. That means it is endothermic reaction, students. That means what we can say, endothermic dissolution. This one is endothermic dissolution, students. Here heat is absorbed. Heat is absorbed, students. Clear? Endo means absorb, thermo means heat. Heat is absorbed. Clear this one? Endo means absorbed, thermo means heat. Heat is absorbed, students. Why, students, here it is endothermic reaction, heat is absorbed? Because here AB attractive forces are weaker than. That means in between the two different components, attractive forces are weaker. Correct or not? Attractive forces are weaker. So that means to break this, here AA, attractive forces, if you see, these attractive forces are stronger. Correct? That means here more energy is required to overcome the attractive forces. More energy is required. So that's why energy is absorbed more. Here energy is more. But here AB attractive forces are weaker. Kada? Between the two components, attractive forces are weaker. That means during the formation of bond, very less energy is released, students, because here attractive forces are weaker. Clear this one? Attractive forces are weaker. Understanding? So it is endothermic dissolution. Endothermic dissolution means what, students? Here heat is absorbed in the case of positive deviation from Raoult's law. Clear this one? Because AB attractive forces are weaker than AA and BB attractive forces. Clear this one? Attractive forces. That means in between the same components, AA and BB attractive forces, same nana. Attractive forces are stronger than AB attractive forces. So that means to break these attractive forces, to overcome these attractive forces, students, more energy is required. So that's why here heat is absorbed, students. That means it is endothermic reaction when compared to AB. That means during the formation of bond or new bond is formed between the solute and between the two different components, students, here less amount of energy is released. Are you following? So because in between them attractive forces are weaker. Clear? So that's it is endothermic reaction. It is an endothermic dissolution, students. Here heat is absorbed. Now coming to the third point, students, in the case of negative deviation from Raoult's law. What is the negative deviation from Raoult's law? See, students, in this case, third point, in this case, Nana, what is the third point, students? Here delta H mixture, okay na, it is less than 0, students. Okay na, or mixing, change in enthalpy by mixing, it is less than 0. That means it is exothermic dissolution. It is exothermic dissolution. Exothermic dissolution, students. Okay na, dissolution, heat is evolved. Here what, students? Heat is evolved. Clear this one, heat is evolved. What this one Anna? Delta H value, change in enthalpy value less than 0. Why students here AB attractive forces are greater? That means during the formation of bond between the two different component students, here more attractive forces are there. So that's why here during the formation of bond between the two different particles, between the two different component students, here more amount of energy is released. Okay, now released when compared to AA BB. Now see students, between the components AA and BB, attractive forces are weaker. So that's a very less amount of energy is required to overcome or to break these attractive forces. And here AB attractive forces are strong enough. That's why during the formation of bond between the two different components, here more energy is released. Are you following? So that means here absorbed energy is always smaller than the released energy. So that's why here if you see the delta H value, if you calculated absorbed energy minus released energy, if you calculate, you will get the more energy. Which one is released here? More energy is which one? Released energy. Are you following? So that means exothermic reaction, because here AB attractive forces are greater kada. So that's why during the formation of bond or between the formation of bond between the two different components, more energy is required, more energy is released. Students, released means what? Exo means released, thermo means heat. So here heat is evolved. Are you following students in this case? Okay, now in the case of ideal solution, students, what I told, ideal solution, so delta H value equal to 0, because attractive forces between the two components, suppose this is the first component A and this is the B component C. Between the same component, students, attractive forces, and between the two different components, attractive forces are same. So that's why here how much energy is required? The same amount of energy is released during the chemical reaction, students. That means during the dissolution. So that's why here heat is evolved. Neither heat is evolved nor absorbed during the dissolution. But in this case, positive deviation, students, AB attractive forces are weaker. Correct? Attractive forces are weaker than AA and BB attractive forces. So that's why what will happen, students, here in between the two different components, attractive forces are weaker. So that's why here very less amount of energy is released, and in this case AA and BB attractive forces are strong. So that means here more energy is required. So that means in this case, students, in this case more energy is absorbed. Clear? During the dissolution. So that's it is greater than 0, delta H value will get the positive value. But in this case it is exothermic reaction, because during the formation of bond between the two different components, okay, between the two different components, students, attractive forces are here greater, more. That means more energy is released, students, when compared to the required energy, absorbed energy. So that's why exothermic reaction will get the less than 0, because absorbed energy, here released energy is more. Correct? Here absorbed energy is less. That means absorbed energy minus released energy, you will get the exothermic reaction. It is less than 0. Less than 0 is nothing but negative value. Are you following? Here absorbed energy, it is absorbed energy is more. Here released energy is less. That means more minus less, you will get the positive value, delta H. Here attractive forces are greater kada, two different components. So that's why here released energy is more, absorbed energy is less. That's why absorbed energy minus released energy, you will get the negative value. So that's why it is delta H value is less than 0. It is exothermic reaction. Clear this, students? Now going to the third point, students. What is the third point? See, students, what is the fourth point? So third point I discussed, delta H value is 0. Fourth point is delta V mixing equal to 0, students. Delta V mixing is equal to 0. Okay, now in the case of ideal solution, that means total volume of the solution is equal to the sum of the volumes of the components, students. Sum of the volumes of the components. What, students, here? Total volume of the solution. Total volume of the solution. Total volume of the solution is equal to sum of the volumes of the components. Sum of the volumes of the components, students. Okay, sum of the volumes of the components. This is the ideal solution. Why, students? Delta value equal to 0, total volume of the solution is equal to the sum of the volumes of the component, students, because attractive forces are same na, in between the same components, in between the different components, attractive forces are same, correct? So that's why total volume of the solution is same only, student. It is equal to the sum of the volumes of the components. Clear this one? So that's it, because attractive forces are same. Now coming to the positive deviation. See, students, in the case of positive deviation from the Raoult's law, here fourth point, students, here delta V value is here delta V value equal to 0, but in this case, students, delta V value, it is greater than 0. Delta V mixing is greater than 0. That means volume is increased after dissolution, students. Here volume is increased. Okay, volume is increased after dissolution. After dissolution, students, here volume is increased. That means solute, and that means two components whenever mixed, students, here volume is increased, students. That is after dissolution volume is increased. Why, students, volume is increased? Because we know that in the positive deviation, AB attractive forces are, that means in between the two different components, attractive forces are weaker, correct now? So here I discussed na, AB attractive forces are weaker than AA and BB attractive forces, correct? So AB attractive forces are weaker now. So that's why what will happen, students, between them, that means two components are in between them, that in between them attractive forces are weaker. That means AB components are not closer, students. That means little bit they are maintained in the gap. That means in between them, because attractive forces are weak now, that means the components are move away from each other, students. So that's what will happen after dissolution. The volume is increased, students, correct or not? AB attractive forces are weaker than the components AA and BB. So that means here after dissolution, that means after the formation of AB, and that means the component A, component B is mixed. After that, what will happen after dissolution? The attractive forces are weaker, no? So that's the components AB components are move away from each other, because attractive forces are very weak. Okay now, so that's why they are move away from each other. So that's what will happen, students, volume is increases after the dissolution. But in the case of negative deviation, see, students, AB attractive forces are greater than AA and BB attractive forces, correct or not? That means AB attractive forces are greater. That means the components after dissolution, what will happen, that the two different components are very closer to each other, students. That means they are come closer to each other. That's what will happen, volume of the solution decreases, students. Are you following? Here the two components attractive forces are strong. That means what will happen, attractive force is strong. That means the two components are come closer to each other. But in this case, attractive forces are weaker. So that's the two molecules are move away from each other. That's what will happen, the components are moving away from each other. The volume of the solution increases. In this case, volume, here the molecules are come closer to each other, correct or not? The two components are come closer to each other. So that's what will happen, students, the solution volume is decreases, students. Here clear this one? Okay, right. So what is the fourth point, students, in the case of negative deviation from Raoult's law? Fourth point, delta V mixture is less than 0. Clear? Less than 0, volume is decreased, correct? Volume is decreased. Okay now, so volume is decreased, students, after dissolution. Clear? Volume is decreased during dissolution. Okay, during dissolution, volume is decreased, students. Clear this one? This is the fourth point. Now going to the fifth point, students, here total pressure of the solution is equal to the partial pressures of the components A and B, PA plus PB, students. In the case of ideal solution, students, what we can write, fifth point, you see, students, fifth point, total pressure P is equal to PA plus PB. PA plus PB, students. That means here total pressure is equal to the partial pressure of the component A, partial pressure of the component B. Clear? Because interactions are same na, AB, BB interactions are same. Correct? So that's the partial pressure of the component A is equal, the total pressure of the solution is equal to the, because here attractions are same, that's why AB attractive force is same, BB attractive force is same. So that's what will happen, the total pressure of the solution is equal to the partial pressures of the components, individual components, partial vapor pressures of the components A and B, sum is equal to total pressure. Clear in this case? But what about in this case, students? AB attractive forces are weaker kada, that means the solution attractive forces in between, in solution nana, that two different components attractive forces are weaker, correct or not? Here AB attractive forces are weaker, correct, in solution. So that's what will happen, students? Solution total pressure is, it is greater, correct or not? Because weaker kada, solution vapor pressure, solution pressure is, total solution pressure is greater than individual components vapor pressure, students. That means PA and PB attractive forces. That's what we can write, students, here. Here what we can write, fifth point, P is greater than PA plus PB. Okay, now PA plus PB, students. Okay, so because here P is the solution pressure, students, this is the individual components partial vapor pressures PA and PB. So this sum is always it is less, students, than pressure. Are you following? So total pressure of the solution is always, total pressure of the solution is always greater than, because AB attractive forces, solution attractive forces in solution, different components attractive forces are weaker now. So that's why those components, they can easily evaporate, they can easily escape. So that's why the vapor pressure of the solution is always greater than PA plus PB, students. But in this case of negative deviation, students, what we can say here, AB attractive forces are greater than AA and BB nama. So here AB attractive forces are greater than AA and BB attractive forces. So that's why here AB attractive forces are greater. So that's why those components can easily evaporate, students. No, they cannot evaporate. So that's why what will happen, the partial pressure of the solution is always smaller than the partial pressures of individual component, students. So that's what we can write, students, in the case of fifth point, in negative deviation from the Raoult's law. Fifth point, students, P is always less than PA plus PB. Clear this one, PA plus PB. But we know that PA is equal to what, students? PA plus PB na. So PA is equal to PA not into XA, PB is equal to PB not into XB. Correct? Here also same thing, students. This is the fifth point. Clear? Now coming to the sixth point, students. What is the sixth point? In the case of ideal solutions, all attractive forces are same. Correct? In between the same components, in between the different components, attractive forces are same. So that's why here escaping tendency of A and B same nana. Clear? This is sixth point, students. Escaping tendency is same. Clear? Escaping tendency of A and B are same. Okay, but in this case, students, here AB attractive forces same kada, attractive forces are weaker na. Here AB attractive forces are weaker, correct, than AA and BB attractive forces. So that's why here escaping tendency, AB components, how students, AB components escaping tendency is higher. Okay, now it is more, escaping tendency is more, because AB attractive forces are weaker. So that's a solution escaping tendency. That means the two components, different components escaping tendency is, it is more. Here AB attractive forces are greater kada, AB attractive forces are greater. So that means it is more, attractive forces are greater. So that's why they cannot easily escape. So that's why escaping tendency is AB components less. Here escaping tendency, because attractive forces are weaker, so that's why escaping tendency is more here. Okay na. So what we can write, students, here last point, sixth point nana. What is the sixth point, students? Escaping tendency. Escaping tendency of A and B. A and B is more. Here escaping tendency of A and B components less. Clear this one, students? A and B less. So these are the differences between ideal and non-ideal solutions. Clear this, students? Here what we discussed: ideal solutions, the difference between ideal and non-ideal solutions. So first of all, Raoult's law we discussed, correct? Raoult's law. After that, ideal solutions, non-ideal solutions, differences. They obey Raoult's law, they do not obey Raoult's law. Here attractive forces are same between the two. Suppose A component, B component, between the A component, between the BB components, between the two components, different components. This is the solution, students. Are you following? So this is the solution, students. This is the solution. Okay, now that means two components are mixed. This is arrow. This is the first component. Clear this one. This is the first component, and this one is the second component. Clear? So second component, both are volatile solutions you are taking, students. Okay, now clear this one. Both are the volatile solutions. The first component, this is second component, this is a solution. So that means in between the first components, same components, and between the different components, attractive forces are same. But here attractive forces, AB components, here this is which one, students? This is the solution. Clear this one. This is the solution. So attractive forces are weaker than AABB. Here also AB is what, students? What it indicates? Solution, this one. So attractive forces are greater than AA and BB. Okay, now here attractive forces are weaker. So that's why here interactions are same. So that's the delta H value is what, students? Is 0. Neither heat is evolved nor absorbed during resolution. But here delta H value is greater than 0. Why, students, here greater than 0? Because here solution attractive forces are weaker. Because in the formation of solution, during the formation of bond between the two different components, students, here attractive forces are weaker. So that's a less amount of energy is released. But here more attractive forces kada between the two components. So first of all, these bonds have to break, then only they forms the solution. They can mix with one another, correct or not? So first these bonds to have to break. This is the first component, this is a B component, both are mixed nana. So in the first component, attractive forces, B component attractive forces, first have to break. To break the attractive forces, energy is required, more energy is required, because attractive forces are stronger. Okay, now more attractive forces. So that's why here more energy is required when compared to released energy. But in this case, that's why it is endothermic dissolution. That means heat is absorbed. In this case, students, attractive forces, solution. During the formation of new bond between the different components in the solution, the attractive forces are greater. So that means here more energy is released, students. Are you following? Because attractive forces are greater, so that's more energy is released. In the case of A and BB, less energy is required. So required energy minus less energy minus less required energy minus more released energy, then you will get negative value, exothermic. That means what? Heat is released here because attractive forces are greater. That's a more heat is released. Are you following? You remember one point, students. During the breaking of bond, always energy is required. During the formation of bond, energy is released, students. Okay, now. So and after that, here enthalpy, next delta V value, it is 0. Total volume of the solution is equal to sum of the volumes of the components. What about this one? In this case, here attractive forces are weaker kada. So weaker means the components are moved away from each other. So that's what will happen. Distance between the space between the components increases. That means volume increases, correct? So delta is greater than 0. It here volume, because attractive forces in this case solution, different components, attractive forces are stronger. That means the molecules are very closer to each other. So that's what will happen. Volume is decreased. In the case of here, that partial total pressure of the solution is equal to Pa plus Pb, because same attractive forces. So that's what will happen. The partial pressure of the vapor pressure of the component A, B, sum both are equal to the total pressure. Here P is greater than, here P is less than. Here escaping tendency of AB components are same, because same attractive forces kada. So here escaping tendency of A and B is more, because here AB attractive forces are weaker. Here escaping tendency of A and B is less, because attractive forces are greater. So that's why they cannot escape easily. Okay, students. Okay, thank you, students. I hope you like this video. Thank you, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much.